Hi, I'm Mrs. B, and we're going to talk about science. Today, we are going to focus on particles and matter. Can we see all matter, or are there some things that are too small to be seen? So let's first start off and review our 5 senses, because in science, it's always important to use them in order to make sense of what's going on around us. So, 5 senses review. What do we hear? What do we smell? What can we taste? What can we touch? And what can we see? So, I want you to observe and use your 5 senses, and I'll use my 5 senses to see what I'm going to do and explain what's happening. Okay, so what did you hear? Were you able to hear anything? I heard the balloon blowing up. What did you see? I put my mouth on the balloon and I filled it. What else did you see? Can I taste anything? No, I don't want to taste this balloon. I feel the balloon. It was flat at first, and then it filled up. And I can release whatever's in here as well. So what do you hear? And I feel something on my face. So, do you have some questions about what you just saw? What kind of a question do you have? Start with the what question. What was in the balloon? How about a what if question? What if the balloon was filled with something else? How? How did this balloon make sound? When? So, what was in here? Air. Where was the air coming from? It was coming out of me. And so everything around us, including ourselves, is made up of matter. And that's anything that takes up space and has mass. And what I was blowing into the balloon, air, can also be referred to as particles. Particles are actually the smallest unit of a substance. So if we kept breaking something down, maybe tearing a piece of paper over and over and over until we couldn't tear any little piece of paper down, we could still, by other means, break it down until we were at a particle. Again, a particle is the smallest unit of matter. And another name for air is gas. And gas is anything that is a material that's not liquid or a solid. So let's look at some other examples of matter, because air is matter, that we can't necessarily see with our eyes. So here I have a glass of water, and I'm going to add some sugar to it. I know what this substance is, so I could taste this, but I'm not going to touch my face. I'm going to take a spoonful of sugar. I'm going to add the sugar. Can you see the sugar? You able to see that there's a substance in here now? So I'm going to stir the sugar. And what do you predict will eventually happen? I have a lot of sugar. It might take a couple of seconds here. So the kind of sugar I put in here is called unrefined. So it looks like it has a brown color to it. What do you think I'm trying to do with this sugar? I'm trying to get it to dissolve. Have you heard of that word before, dissolve? Have you ever added sugar or some kind of a powder mixture that you drink? Maybe sugar to some tea? What happens to the sugar? I can still see some of it, but a lot of it went away. Did it disappear? Where did it go? Is it gone? Can I get it back? What do you think would happen if I boiled this? Would I get the sugar back? How do I know sugar's in here? Well, I could taste it and it would taste sweet. So what happened to the sugar? Does it still exist? What about this hand pump? I think this is used to make balloon animals. Let's see if you can hear. Can you hear the air coming out of that? So I'm going to take a piece of paper here so you can see what's coming out. Air, gas particles were coming out of this. Do you know how a hand pump works? I can hear it working. I can feel the gas or the air particles coming out of it, but I don't see the gas particles, but they do exist. What about sports? Have you ever had to fill up maybe a soccer ball, volleyball, football? Have you ever used a pump? How does a pump work? Let's see if you can hear this. Let me put it near my mic. And I can feel it too. So even though I don't see anything coming out of this pump, I can hear it, I can feel it, and if this was flat, it would inflate. So here's one more example. Have you seen this before? Does this look familiar? Is it water? Is it soda? How could we test what's in here? I'm going to give it a shake. It's very fizzy. Did you hear that? Let me do that again. So, do you think it's water or do you think it's something else? What is coming out of this bottle? Whoa, it's about to overflow. So if you think it's soda, it is soda. What's in there? How did it go from being still, no bubbles, to suddenly having bubbles? There's gas in our soda. You ever burped after taking a big drink of a carbonated soda? So there are particles everywhere around us and matter that we can't see with our eyes. But there's lots of evidence using our senses that they do exist. So I challenge you to create a model. And so when we create a model, let's include 4 things. Let's include in our drawn model some keywords. So some keywords we had today were gas and particles. So I do include that in my model. Some kind of an image or a picture to represent whatever it is we're trying to explain, something that's happening, how something works, how parts fit together. We also want to include some symbols. So for example, we can use arrows to show direction. Maybe they're going left to right, or they're going in a circular fashion. What else do we want to have in here? Some words and some sentences to explain what's going on. So here's a representation of me blowing up my happy face balloon. Here's the balloon before I filled it. It's kind of flat, no gas particles. Then I blew into the balloon and I filled it with gas particles. This part here is supposed to represent like those cool images where they zoom into something. And I used dots to represent the gas particles Notice that I didn't put the particles, the little dots, very close together because it's a gas. So what's something going on around you? What's evidence that you're collecting from your five senses of matter that you can't see with your eyes? What are some other examples you can think of? What questions do you have about that? Challenge yourself to come up with a what question, a what if, a how, a when, a why, and then to draw up an example, a representation of what you think is happening and share it with someone. Thanks for joining me today. See you next time.
Welcome to 4th and 5th grade mathematics with at APS
At home.
at home, with APS at home. Hi, my name is Mrs. Gaudette.
And I'm Mrs. Sears. Welcome, mathematicians.
And today we're going to start you off with a problem that I have not done with you guys before, but if you've been watching, we did earlier this week on the 2nd and 3rd grade math. So with that, we have something that's called which one doesn't belong. On this one, we have a 9, a 16, a 25, and a 43. And you have to decide which one doesn't belong and why it doesn't belong. So if I was to look at this, the first thing that pops in my mind is the 9 doesn't belong. Because that 9 is a single digit when all the others have 2 digits.
See, and I thought the 9 different than the rest of the digits because if you added up the digits of each of these numbers, the 1 and the 6, the 2 and the 5, the 4 and the 3, that 9 wouldn't belong because they don't add to 7. So
Wait. So you're telling me 6 and 1 is 7.
yeah, 2 plus 5 would be 7.
I didn't even see that.
4 plus 3 would also be 7, but 9 wouldn't belong to me because it's not a 7. It doesn't add to the 7s. You can't take the digits and add them up to 7.
All right.
So,
All right, I'm going to say 43 doesn't belong. Because 43 is, with our vocab, I'm going to bring out that vocab word, prime number. It is a prime number, meaning the only factors of 43 are 1 and itself, where all the other 3 numbers are composite numbers. Look at that. I'm all proud of myself. Look at that. They have 1 times itself, but they also have something else. 9 has 3 times 3. 16 has 2 times 8, and 25 also has 5. It's divisible by 5.
well, okay, so I'm going to get rid of 43 as well, but for a different reason,
All right.
okay? My reason is I'm going to go back to a fact family. I think 9 plus 16 would equal 25. So if you had 16, 9, and 16 plus 9 would be 25, you wouldn't need the 43. And if you did 25 and 16, it wouldn't be 43. So fact family, 9, 16, 25, 43 doesn't belong.
She really likes those fact families. All right, I'm going to say 25 doesn't belong. Because, so I got to switch with you.
Yeah, there you go.
Because the last digit, 9, is divisible by 3, meaning 3 can be divided into it. 6 is divisible by 3. 3 can go into it twice. And 3 is divisible by 3. So I'm going to say 25 doesn't go in there.
I don't know if I know one for 25. I'm going to have to think on that one for a little bit. But for now, I don't know. The one that's just jumping out at me because of doing the number of the day is 16, because all the rest are odd. This is the only even number. So 16, I think, doesn't belong because it's even and the rest are odd. So,
Okay. I'm going to also say 16 doesn't belong, but my reason is different from yours. 16 has more than 3 factors. So if we go to our factors, 16 has 1, 2, 3, 4, 5. 9 has 3, 25 has 3, and 43 only has 2.
Okay.
Because it's a prime number, only has 2 factors.
Okay. I don't know. Let me think here. 9, 16, 25, 43. 25.
I can come up with another one for 25.
Okay. I haven't thought of one yet for 25. 25's eluding me today.
25 eluded me actually for a very long time until I, of course, talked to my husband. Thank you very much. He gave me some ways of why 25 doesn't belong. Did you figure one out?
I didn't quite figure one out, but I thought of a different one for getting rid of 43 again. And the thought, it brought me back to what you were talking about here earlier, and I know that's one of the vocabulary words we're going to talk about, is 9, 16, and 25 are all square numbers. So if you squared 3 squared is 9, 4 squared is 16, and 5 squared is 25. 43 doesn't have a square. So I'm going to say 43 again, but no, I still haven't come up with 25. 25's, I think I asked my husband on this too, and he couldn't come up with one.
All right, I got it.
All right.
So if you take, so I need to switch with you again.
Okay.
I have to
get out
find.
of here.
So if you find the product of all the digits in each number, it should be, if I've done my math right, divisible by 3. 9, is that divisible by 3?
Yes.
Yeah. What about 1 times 6?
6.
Is 6. Is that divisible by 3? And what about 4 times 3? 12. Is that divisible by 3? Yep, 4 times. But if I did that with this one, 2 times 5 is 10. Is that divisible by 3? Nope.
Oh, clever.
Right?
So I did the sum of the numbers to figure it out, but you did the product of the numbers to figure it out. Very, very clever. Huh.
So this activity is called Which One Doesn't Belong? And you know, if we've just found a few for each number, I bet you can find some for each number.
Definitely.
So that's what I'm leaving this with you, is that try to find out which one doesn't belong and why. So last time we were together, last few times, I've had several vocab words that I wanted to just go back over and make sure that you remember what they were. So we started with the first vocab word, equivalent fractions. This one was all about finding the numerator and denominator that are equivalent on 2 fractions. For example, 1/2 and 2/4. And I'm going to move this just a tad over. We just went over prime number and composite, right? Where a prime number is a number that only has 2 factors. One, oops, did I hold it up nice and upside down? All right. So that one is the just 1, and itself is the factors. Composite has more than 2. So, for example, 6 has 1 times 6, but then it also has 2 times 3 to be able to get you those 4 different factors. Then last time we met up, we talked about several different, 3 different ones. Remember Ms. Sears made a foldable with you? Do you remember that? If not, we're just going to go over these really fast. So the first one, a factor, is really we're trying to figure out numbers when they're multiplied together, factor pairs can get a number. For example, our 6. 2 and 3 are factors of 6. So that was our first one from last time. Then the next one we had was multiples. I know we've been talking about this one a lot. With a multiple is, if we say 3, the multiples of 3 is what? 3 multiplied by a number. So like 3 times 2, 6 is a multiple. 3 times 3, 9 is a multiple of 3. And our last one, Miss Sears beautifully talked to us about, was a square number. And we're going to talk a little bit more about this today. But a square number is a number that when you multiply it's better to do it with an example, like 3 times 3. The square number is 9, or 3 times 3. It's this, a factor multiplied by the same factor. That is a square number. So let us get into where we left off last time. We were reading the book called 2 Ways to Count to 10, and it is a folktale from Liberia, retold by Ruby Dee, illustrated by Susan Meadow, and it is published by Henry Holt and Company. What this book was about was the king, the leopard, had decided that he's not going to live for the rest forever and ever, and he needs someone who can come in and take over his kingdom one day and be able to make sure that that kingdom stays safe, keeps going. And what he did is he said, the person who's going to be, to take my place has to be not just strong, but has to be smart. And so the little thing he had all of the animals do is they took his spear, threw it up, and they had to count to 10 before the spear hit the ground. So it started with the elephant came, went 1, 2, 3, 4. Nope, didn't make it. Then we had multiple other animals. Even the lion came in and says, I can do this. He threw that spear up and said, 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, it hit the ground. Even the mighty lion couldn't do it. But then this little antelope came in. I'm looking at thinking the lion. They're pretty thick, thick arms, big boned. And then you come up with these skinny little legs, antelope. And they came up with a different way to get to 10. He threw that spear up and counted 2, 4, 6, 8, 10. He said 5 words before the spear hit the ground, and he made it to 10. That was our story we read last time, but we had an activity that was taking that idea, knowing that we counted to 10. I'm sorry, I'm going to move this. Know that we count to 10. Most of the animals counted by ones. And then he went ahead, the antelope counted by 2s. And then we found out as a group that we could count by 5s, 5, 10, or we could even count by 10. 10. So there were 4 different ways to count, or because we're using our academic vocabulary, we are talking about what are the factors of 10. So we did that for 12. We then did it through 1 through 20. And I had left you to say, try out, find some more factors, keep going. Now I want you guys to think about what are some strategies to find all those factors. Could you have just started with 1 and then you go, okay, I can get to 20 by 1 times 20. Did you go to 2? Yep, I can get to 2 times 10 to get to 20. Did you go by 3? Can 3 go into 20? 3 times 6 is 18. 3 times 7 is 21. Nope, that didn't work. So 3 wouldn't have been a factor. Then we could have gone to 4. What times 4 gets to 20? 5. And then I know that 5 is my next number, and I already have it. So I'm done with my factors. What else could I have done? Did you use a multiplication chart? Did you take that chart out and go, 20. Every time I found 20, that would help me find the factors? Did you use a calculator? Right? You could have used a calculator. You could have done repeated addition. Divisibility rules. The Mrs. Sears on the side saying, what about the multiplication arrays? Yeah, right? When we do those arrays, we say, oh, it's a 1 by 20, so we have a 1 box by 20 boxes, right? So those are just some ideas of strategies that we could have done. Now we're going to go ahead and continue doing our factors to find out some more information before we start to look at patterns. So I have 21. 21 has factors of 1, 3, 7, and 21. I always double check my math, and I always wanted to make sure. So I know that 1 times 21 is 21, and 3 times 7 is 21. Okay. So you notice I remember last time we had talked about the rainbows. That helps me. Or factor pairs, putting factor pairs together. Like 1, let me give you an example of what I mean by that instead of just trying to mime it with my hands. Mime it, meme it. So for 21, an example what I mean by factor pairs, we do 1 times 21. That's odd, so 2 can't go into it. 3 times 7 is 21. I know 4 can't go into it because it goes into 20. 5 can't go into it because that goes into 20 also. 6 does not go into it because 6 times 3 is 18. And then I'm at 7. I made it. All right? So that's what I mean by factor pairs. That was another strategy that I really like to use. So how many factors do we have there for 21? Right? Thanks for shouting that out to me. There's 4. For 22, I already know that 2 can go into it. Why? It's even. So for 22, we have the 2 and 11 and the 1 and 22, which is how many ways? Thank you so much for telling me that. All right, then we have our 23. Can anybody guess what kind of number 23 is? Prime or composite? Got it. There we go. We knew it was prime. So we only have 2 ways. Then we have 24 and 25. I'm going to just go ahead and put both of those up right away. 24. Oh my goodness gracious. Did you see that with 24? There is how many ways to get to 24? I don't know yet, so let me count. Oh my gosh, you're right. It was 8 ways. Whoa. 25 had 3 ways. And then we have a couple more we're going to throw up here. So I have my 26, 27, and 28. So 26 had 2 times 13, so that's 1, 2, 3, 4 ways. We knew 2 could go into it. 2 can't go into it, but if you add your digits, right, divisibility rules, 7 plus 2 is 9. 3 can go into it because 9 is divisible by 3. We have 4 ways. 28 had 1, 2, 3, 4, 5, 6 ways. Then we're going to go into a few more. And the reason we're going over this, boys and girls, is because we don't want to just look at one number and figure out just one number in their factors because, that's fun, but sometimes there's ways to look at that pattern. Remember I had asked you guys to start looking at that pattern and think about what is going on there. There is a reason to my insanity. There is something going on here. There's 2 ways for 29. Oh my, look at 30. 1, 2, 3, 4. 8 ways. And 31 had 2 ways. So if we put a few more up, and this should help us figure out our pattern. So I'm going to start with 36. I'm all over the place. Two of them didn't get stickies on it. 35, 33, and 32. So let's just go ahead really fast and count up how many factors we have. We have 6 here. Oh, thank you for shouting that out. I appreciate the help. Oh my, did you see 36? Wow. All right. So welcome Miss Sears back.
I'm just looking at all of these different factors and different ways to count up to these numbers. What do you notice so far? I mean, I'm noticing a lot of different things.
Well, since I'm going to go with my academic vocabulary, did you notice all the prime numbers?
Yes.
Right?
The ones that I can see that are prime numbers are going to be the only ones that have 2 ways to get to them.
Huh.
Because it's only that and that number and the number 1.
Wow.
And
Right.
I mean, I see square numbers there too.
So before we go with that, let's list all the prime numbers to 50.
I'm going to go over here.
So let's start that list. I know earlier, last week, we had listed all the prime numbers to 10. Let's see if you remember that. And you also have a nice little hint. So we have the 2, 3, 5, 7, not 9.
7.
7.
Yeah.
Yep. 11.
13.
13.
17.
17. 19. Not 21. 23.
23.
Not 25. 20. Nope, not 27. 29. Oh, you're...
I'm showing. I'm like, see,
You're showing them, and I'm like sitting here. I'm sitting here like, trying to figure that out.
31.
31, 30, not 33,
And I
not
think
35.
that's it to where we have right now.
All right, well, let's list the rest to 50. So it's 37. Do you think 37 would be prime? It is. It is prime.
Let me put it up there.
Put that up there. It is prime. And then the next question I had for you, because what else do prime numbers have to be besides 2? 2 is, remember, the oddball one that is prime and even. But what are all the rest of them? They're odd, right? Thank you. So we're looking at the odd numbers as we go through. So it's 39 prime. Nah, no, it's divisible by 3, so we know 3's in there. So that one's not prime. What about 41? All right, 2 can't go into it. 3, 4 plus 1 is 5, so nope, 3 can't go into it. 4 has to be an even number. 5 has to end in 0 or 5. 6, it has to be an even number. 7, nope, 7 doesn't go into that evenly. And then that's pretty much 8, 9, yeah, nope, 41's prime. All right, let's look at 43. Is 43 prime?
Didn't we have this question before?
Use your clues to help you. Thank you, Mrs. Sears.
I thought so. I was going to say 43 sounds familiar to me, but I didn't think it was. I think it is prime.
Right?
Yeah.
All right, so we had 43 is prime. Is 45 prime? It ends in 0 and 5. 0 or 5. Let me rephrase that. Yes, so it is not prime. What about 47? Is 47 prime? I knew 1 times 47. 2, nope. 3, nope. 5, nope. I think 47 might be our next prime number. Am I correct?
Let me see. I think so, yes.
47. And then our last odd number to 50 is 49. Is 49 prime? Does anybody remember their multiplication? Right, 7 times 7 is 49. So,
It's a square number, I know that.
well, then thank you, Mrs. Sears. Let's talk about our square numbers. So if we have, these are all, this is just some random numbers with no title on it. So let me go ahead and write prime numbers.
Should I go ahead and start filling in some of those on the chart, or are you?
Sure.
Okay, let me get a
Go
few.
ahead while we talk about this next one. What were these called? 1 and 21 together, 3 and 7 together? That's right, factor pairs. I'm really bad sometimes, kiddos. I'm the worst person sometimes with giving titles, but just random things on paper doesn't mean anything. Remember that. You've got to put something on there to tell us what that is. So let's talk about our square numbers that Mrs. Sears reminded us of. So what would our square numbers be? Well, remember, it's a factor multiplied by itself to get that product. So 1 times 1 is 1. That is a square number. Would 2 be a square number just by itself?
By itself? No.
No. It would have to be 2 times 2, which is
4.
4. And then, can you list the next one? 9. Thank you. I appreciate your help. So, before I go on to the next one, because I know you guys you're raising those hands, you're telling me, oh, I know. Was there a pattern with square numbers? So let's look at 1, 4, and 9. What do we notice? Well, 1 has 1 as a way to count it, and only one factor. 4 has 1, 2, and 4 as our factors, so there's 3 ways to get there. 9 has 1, 3, 9 as factors, so there's 3 ways to get there. Based upon that, do you think you might have a pattern? Maybe. Let's see. That it only has 3 ways to get there. All square numbers might only have 3 factors. Let's see if that's true. All right. So what would the next one be? So we had 1 times 1, 2 times 2, 3 times 3. I knew it because you guys were raising your hand earlier. 4 times 4, which is 16. Does 16 only have what you predicted was the pattern, only 3 factors? No, 16 had. Do you think you have a new pattern that you might predict for all square numbers? Maybe. Maybe it just has an even number of factors. An odd number of factors. Let's see. Let's try a next few. So we know 16. We know 5 times 5 is 25. 6 times 6 is 36. So let's look at that really fast. 25 has 3 factors. Your first prediction was almost correct. 6 times 6, which is 36, and I'll wait for Miss Sears.
I don't think you have these in there, so I'm adding them in.
Because that was their homework.
Ah.
So we have here the square numbers. 6 times 6 is 36. So let's look at 36. It has 9. Is that it? Oh, you're right. It's an odd number. So what would our 450 be our last
Square number?
square number? So our last square number, 7 times 7, which is 49. Good job, you guys. So while we were talking about square numbers, Mrs. Sears has nicely went through and given us all the factors up to 49. So some of you might have been smart and been watching what she might have been writing. No, yay.
You can't see it.
You
thankfully.
can't see it because my book, ha, ha, ha. So my next activity, perfect. So because of that, she went through and she listed all the factors from 1 to 49, what all of them have. And again, on 49, you notice it has 3 factors. So that is true. Our pattern, we said that all had odd numbers. Did we notice any other patterns? Well, I noticed one. I'm going to use my divisibility rules. I noticed that if a number ended in 5 or 0, the 5 was a factor. Did you notice any other patterns?
What about the odd numbers? Do the odd numbers have anything special about them? Let's see. 3, 5 has 2. 7 has 2. Oh, but no, 9 has 3. Oh, maybe they might just have only a few. The odd numbers?
Well, I noticed because we were talking about, for example, 12 and 6. So the factors of 6 are 1, 2, 3, and 6. Do you notice something that's also in here? Did I do this? Yeah, I did this right. Yes. So we have 1, 2, 3, 6. I noticed that pattern.
So what about when you're saying the even numbers? Because I'm thinking the even numbers have something to do with that too. Don't the even numbers have like half of that number? I'm trying to look. Because the even numbers look familiar too. Like 24. How many does 24 have? 24 had quite a few. 8.
24 had a lot. Had a lot of factors. Are you saying even factors, even numbers might have more factors?
Yeah, I mean, it looks like it because look, even 48, which is double of 24, has more factors. It has 10 factors.
Wow.
I was just thinking 24, 2 and 4 is 8. That's what I was thinking. 2 times 4 is 8. But that's kind of strange that worked out. And then I was also trying to look and see if anything else would work like that with the numbers. But no. But those even numbers, man, they have a ton of factors. The odds don't have near as many. And of course, when you do have a prime number, it only has 2. And so it would be really quick to find those prime numbers really fast.
Oh, yeah. So you notice we, Miss Sears and I, as we're talking, have patterns, and we're noticing more patterns than what we have even talked about prior to today. So see if you can find out some other patterns as you're looking through it. And then I have a little assignment for you. Miss Sears tried to be a little sly on me there and tried to fill in the factors of 50, but luckily I had my book there and you couldn't quite see it. So what I'd like you to do, and we'll talk about this next time, is I'd like you to come up with all the factors to 50, tell me how you know you have all the factors, and tell me how you got them. How did you figure it out? So we're leaving you with a couple of assignments this time. This next piece that we're going to do is my favorite game in the whole wide world. I would play this with my students in my class all the time. And the deal was, how I always introduce this, is they, and there was a collective they. Yes, you can see I like Star Trek. I like that word collective. They had to see if they could beat me. Let me first go over the rules of the game with the product game. What does product mean? Right? Product is the result of 2 numbers multiplied together. It's the answer. So with this, you will need a game board, and then you will need 2 paper clips. We can't use paper clips, so we have gotten some sticky notes to use for our paper clips. And then you'll need some counters, something that could hold your place on here. We're going to use Post-it notes, like if you had, last time we had talked about eraser tops or stickers, little stickers, if you have that at home, rocks.
If you have money, you can like put money or even just cut out circles on your paper and use those as counters. You can put your initial on it so that you know it's you, or put your name on it if you have the same initial.
All right. The object of this game is to get 4 in a row. Just like, I was going to say tic-tac-toe, but it's 3 in a row. Connect 4. You can get them horizontal, vertically, or diagonally.
Does this have one of those where you could do the 4 square?
Nope. Last time, we did discuss there were several other games that had 4, a 2x2 square, but this one does not.
Okay.
So this one only has horizontal, vertical, or the different diagonals. What you have to do is the very first person will take their paper clip. I'll give you your paper clip. And then you put it on a number down here of your factors, any factor. So I'm going to say 5. Then player 2, Mrs. Sears, will have to put her paper clip on a factor at the very bottom, knowing that she's going to have to multiply those 2 numbers to get a product, where she'll put her game board piece up here somewhere. So strategy, remember we talked last time when we did games, strategy. It's all about that.
Well, and I mean, I'm just thinking about I only see like 1 5 up there. So maybe let me just put the 5 times the 1.
So unlike those other games that we did talk about, is there's only 1 number of every number here. There's no copies on this one. That's probably why I like this one. Now from now on, we can only move 1 paper clip at a time. So if I wanted to do, like I want 20, so I would do 5 times 4. So I would move this one over to the 4 and get myself on 20.
Okay, so let's see. So I could either move the 4 or the 5 paper clip.
And remember, we had talked about strategy last time. So we're not just trying to get 4 in a row. We're also supposed to be stopping Mrs. Sears from getting 4 in a row.
Let's see. I'm going to do 5 times 2. So I see that 10 right there. I could maybe go for a diagonal, right?
She didn't look a few moves in a row. I now can take that 2 she just moved and put it on 2 times 9 and put 2 times 9 is 18. So I got, I stopped you.
Okay, so I have a 2 or a 9, and I've got to figure out a way to do that. What if I did 2 times 8? Let's see. Move that. Then I could do 16.
Oh, she's trying to stop me. How about, ooh, yeah, I know, I can hear you guys. Well, try that one. It's only 3 times 7, but I can't move both of them at one time.
We don't have that factor.
Oh, okay. So that means I can only move 1. And I want to try to stay in my general area. And by that,
8.
That's an 8. So I'm going to do 3 times 8. It's 24. Now, one of the rules is if you multiply it wrong and get the wrong answer, hopefully your partner's checking your math.
Yeah.
You lose a turn. So then if I had done that math wrong, I lost my turn and I couldn't put my counter down on there.
I don't want her to get that 4 in a row. So I see the 21 here, and I know if we have a 3, I'm going to do 3 times 7, or 21. It's also kind of in a good space for me. Maybe I'll get there.
All right. See, I shouldn't have opened my mouth to tell you what I was thinking. Now she heard it and took my strategy from me. All right. Well, one thing we have not talked about is we are allowed to put 2 paper clips on the same number.
Oh, I didn't know that.
So you didn't?
No.
I never told her. Ha, 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 ha. So 3 times 3 is 9. Boop.
Oh, okay. Well, I still see my 12 there, and I could go down diagonally. So let me try 3 times 4, since we still have that on there. Let's see.
Uh-oh.
All right.
I'm going to have to stop what I'm doing and do 4 times 8 is 32 and stop that. Nip that, man.
Okay.
See, what starts to happen while you're playing is you make it so that you have several ways to get to your whatever your number 4 is, the 4th one in a row, so that no matter the way she moves, you can still get it.
Okay.
But that's thinking several moves in a row, and I haven't quite gotten there yet.
Well, I'm going to try a different way. Let's see. I see that 4 over here, and I know you have a 4 uncovered, but let me go ahead and do 4 times 1 so I can get that 4.
Oh, well, thank you so much.
Did
I'm
I
going
just
to do 2
open it
times
up?
1. Yep.
I do this all the time.
1, 2, 3, 4.
Not looking far enough ahead. Good job.
Thank you very much, Mrs. Sarah.
Air 10. You get a virtual air
If
10.
you guys haven't figured out, Miss Sears and I are very competitive. I don't know about her, but I am.
Yes.
And I admit that. I'm very competitive. I always seem to want to win these games against her. So again, the product game is really just working with you on your multiplication facts, but in a fun way. This is one way that you can play with a family member and work together on this. Sometimes you might be struggling a little bit with your facts. Maybe it is where you and your family member work together to get those facts versus losing your turn every time. So if you're playing with your older brother, my older brother, would have just told me, you're wrong, just to make me keep losing. Maybe sometimes it's better to work together to help each other. So in this, use this game board. Use this to just keep working on it, and I'm uncovering it so you have a chance to look at it, but I will make sure that this gets on our website so that you have a chance to have your own game board of the product game. This, again, is my very, very, very I'm going to say favorite, but I don't think it's quite a word. Very favorite game in the whole wide world. So next time, we will continue on with a math task with the Will Shop Continued. And reminder, what we had asked for you to do was to find out why these might not belong, pick one number and figure out a different way of why it won't belong, and find the factors of 50. Find all of them, tell me how you know you got all of them, and then explain to me how you got them. All right, you guys. So I wanted to thank you again for joining Ms. Sears and I for math today with 4th math and working on factors and multiples. And we wanted to say have a great evening, and thank you for joining us today with At Home with APS. Have a great evening.
Bye-bye.